I'm Jonathan Tanner, and this is my development lead, Mike Shappell. And today we're going to be talking about how to develop PC companion applications with the CE 6.01 preview toolkit. Today, first, we're going to go over a brief overview of the history of the Windows CE OS and the functionality that it supports. Then we'll go through a demonstration of how to create your own MFC application targeting Windows CE. Then we'll explore a little bit about emulation, the remote tools, debugging, and a new technology that we're excited about, Platform Manager. Then we'll talk about application distribution with CEF, the common executable format that you just saw highlighted in the keynote. Then we'll talk about the VCC futures, where we're heading with the toolkit, and what you can expect in later releases. Then we'll go through some of the development tips. And at the end, we'll take any questions that you might have. Windows CE has been around for a few years now, and it supports a large subset of the Win32 APIs. Over 800 are supported today. When they were creating the OS, they didn't want to take every API that was present on the desktop because there were sometimes multiple instances, 3, 4 functions that provided nearly the same identical purposes. So they would take the most functional one down to the CE OS. They did this to conserve on ROM and RAM size for any of the OS running. There are two classes of platform that are currently supported by CE, and I'll talk about those in a second. There's a large set of supported processors. There are currently 5 CPU families, and as you saw, approximately 120 processors that Windows CE can run on today. It takes a small memory footprint, approximately only 500K for a min-kern version of the OS to run in ROM. Low CPU power consumption. It's fully componentizable, especially now with that new platform builder, the drag and drop of the libraries, and a fully extendable driver model. So if you have a GPS system and you want to create a driver for that, you can roll that right into the core version of the OS. What do you need to develop for Windows CE? Well, first, you need one of the desktop toolkits, either VC or VB. Then you need the appropriate Windows CE toolkit add-on, the VCCE or VBCE. Then you need the appropriate platform SDK. There are 2 types. There are the targeted platforms, which include the HPCs, the palm-sized PCs, the HPC Pro, Auto PC, and even Sega's Dreamcast, which will be released later this year. Then there are the embedded platforms, which, as you saw in the keynote, you can create your own custom OS using Platform Builder and export the appropriate SDK for that. And finally, you will also need a physical device to verify your program. What features does the Windows CE Toolkit for 6.0 provide for you? It provides cross-compilers for all supported CPU families, the ARM, MIPS, PowerPC, x86, and SHX. It also is, if you're a VB developer, is the only place that you can create ActiveX controls for Windows CE. Provides remote debugging, 6 remote tools that we'll highlight later, and CE-specific API references to let you know what is and is not present on a per-platform basis included in the SDKs. Right now, Mike is going to take us on a demonstration of what it means to create an MFC application targeting Windows CE.
Okay, what we're going to do today is we're going to look at a couple of different areas of the IDE. I'd like to start off by showing you how to create a framework for an MFC application that runs on Windows CE. We'll begin the process by selecting File New. And the dialog that's presented will allow us to create a new application. For those of you familiar with our previous versions of the toolkit, you'll immediately notice that all the Windows CE wizards are gone. Well, not exactly all of them. We still have this one left. But when I select it, I no longer have the opportunity to pick which processors will be supported by my application. We've changed our logic here. In the past, it was possible to create an application and generate code that would not run on a device. So what we've done is we've changed the logic a little bit to help you to select a wizard that will work for the platform that you're targeting. We'll take a look at our solution to that in just a second. But first, we need to enter a name for our project. We'll go ahead and call it Skeleton. Now, the dialog you see here is new in the 6.01 toolkit that you'll get during this conference. On the left side of the dialog, we have a list of all the installed SDKs and the wizards that they support. On the right side, there's a list of CPUs, again, that are targeted at the platform itself. So if I'm targeting, say, a palm-sized PC, the original palm-sized PC in this case, you'll see that we have less processors available to us than if I pick, say, the HPC Pro. For our purposes, we're going to generate a Windows CE application using MFC. I click Next, and I'm presented with the beginning of the MFC wizard. The desktop developers in the audience, if there are any, will immediately notice that Windows CE supports only single document and dialogue-based applications. There's no support for multiple document interface, or MDI applications. So we'll create a single document application, and the next screen will allow us to select which features we'd like to include. You'll notice that there's a number of options for the command bar. Command bar in Windows CE is a combination of the menu and toolbar. If you intend to use your application on versions 2.0 or earlier of the operating system, then you'll want to stick with the default of MFC-compatible command bar. This is the only version of the command bar that will work on all versions of the operating system. However, you'll also notice that some features aren't available using this version of the command bar. For example, I can't have a status bar. Printing support isn't available. Since in my case I'm targeting a newer version of the OS, I think I'll go ahead and use Internet Explorer rebars. I'll add printing, ActiveX, and even a status bar. On the next screen, I'm happy with using MFC in the shared DLL, and the default names for the classes are just fine with me. When I click Finish, I can confirm all of my selections, and the environment will go ahead and generate the application skeleton for me. You'll notice that a number of classes were generated automatically. We have classes for initialization, which is typically in the name of the project, so in our case, CSkeleton. And we also have mainframe, which will handle the main application window, and an about dialog handler as well. So at this point, we're ready to build our application. I'm going to go ahead and target a release version of the MIPS device. I have a NEC Mobile Pro 800 connected, and I'll do a rebuild all. While this builds, it'll go through and build a version for each. For this processor, at the end, it'll download that executable to my device. And once that happens, we'll go ahead and switch over to the device and take a look at what was created in our skeleton. Okay, as you can see, the application is now on the device. It's called Skeleton. We can go ahead and execute it. And it has the basic characteristics that we would expect. We have a menu. On the menu, we have printing support. We have access to common dialogues like open. And if we just click print, we'll also have that as well. So we have a nice starting point for creating our application. Now we'll go ahead and switch back and continue on with some emulation improvements that we've made.
Thank you very much, Mike. Next, I wanted to talk a little bit about emulation and the improvements that have been made since last year. Currently, we've improved the stability of the emulators. We've tried to clarify the documentation and also reduce the device emulation differences. And another thing that we're very excited about is the fact that applications are now present in emulation. So if you're trying to develop something that employs or uses Word or Excel or the inbox, you can now take full advantage of those in emulation. And Mike is now going to show us a short demo of how useful emulation can be.
Okay, so what we're going to do is we're going to pick up where we left off. The last time we took our skeleton application and we sent it to a device. So why don't we go ahead and kind of do it the reverse way and target emulation this time around. And I'll go ahead and select that I want to do a debug session, and I'll do a rebuild all. Again, the executable will be built, and when it's completion, we'll launch emulation and download this executable to emulation. And I have the emulation environment running on my machine. And if I go over here, again, the skeleton application is there, and it looks very similar to what it did on the device. We have menus. Our menus are functional. We have access to the common controls, including printing, about dialog, all the things that we would expect. And if we exit our application, we can also see that some of the built-in applications, like Internet Explorer, are fully functional. We can actually get to the Windows CE Developer Conference webpage. Okay.
Switch. Next, I'd like to talk a little bit about debugging and a new technology that we've released with the 6.0 Toolkits, Platform Manager. With Platform Manager, you can now create friendly device associations with your device. You can have multiple friendly names for the same device using different connections. We also provide, by default, TCP/IP, PPP, and CE services. While we're no longer dependent upon CE services for our entire connection. Another thing that's great about Platform Manager is that you can now create your own independent transport layers if you're an embedded developer. You can create these and plug them in with Platform Builder, so if you're developing a gas pump or a toaster or whatever you want to use, you can then debug your applications running on that device, even if it doesn't support any of the standard protocols. And I believe Mike is now ready to show us a short demonstration of debugging using this with emulation.
Okay, so just a moment ago, I built a debug version of the skeleton application, and I downloaded it to emulation. So what I'd like to do is set a breakpoint in my application. It's kind of a contrived example, but it's one that I'll use here. If you're familiar with MFC applications, there's an init instance. It's called during initialization of your application. It allows you to do some setup that you need to do before your application is actually visible. I've set a breakpoint at the beginning of that routine. Now I'll go ahead and do a go, which will launch the debugger, and we hit our breakpoint. So now at this point, we can take a look at variables that are in context. Right now, all that happens to be in context is this pointer. And I also put up the call stack so we can see kind of where we've come from. I can single step the way that you would debug any application and expect to be able to do. And as I do that, you can see that the context window contains which variables happen to be in scope at this time. I can go ahead and hit go. My application runs. And it's all of the things that you would expect to be able to do using an interactive debugger. These same techniques that I've just used with emulation can also be used directly with the device. For those of you who haven't had a chance to try it yet, I encourage you to use Ethernet debugging. It's now available in the toolkit and supported by Platman, and you'll find that the entire debugging experience is much quicker and easier.
Thank you. Can we also, while we're here, take a brief tour of some of the remote tools that we have enabled? I believe we have, there's the SPY, Registry Editor, Heap Walker, Process Viewer, Zoom In, and File Viewer.
And all the remote tools are available from within the IDE, and we'll pick just a couple of them. Why don't we take a look at, say, Zoom In first. And I'll get a semi-interesting image on my device to try and grab. Okay, right now we have the nice boring one. Let me refresh my image. Basically what Zoom In is doing is it's pulling a copy of the screen image up to the desktop, and then once we're there, we can go ahead and zoom in on that image. Maybe.
Another thing that Zoom In is good for is if you're trying to create documentation for your users with what your program will look like or what buttons they should expect upon a CE device.
Okay, so it's a nice way to snapshot things. It's also, I've used it in the past to get a feel how someone else has put together an icon, what kind of techniques they've used. It gives you a good feel for what you can do as well. Another remote tool that I'd like to take a look at is Process Viewer. And the Process Viewer will allow you to take a look at which processes are currently running on the device. And for any particular process, say FreeCell, that's the one we were just looking at, I can see which threads are active, as well as which modules the application is using. So the remote tools are very valuable to assist you in the process of developing your application.
And they should also be very similar to those that you've grown used to on the desktop. Next, I'd like to talk a little bit about the Windows CE development process and just an outline of what we recommend that you follow as a model. First, of course, you have to have your idea of what you want as an application, be it something you want to bring from the desktop down to CE, or if it's something that you just want to see on a CE device specifically. Once you've developed it, and while you're developing it, what we recommend is that you use emulation because it's easy to access, and also it doesn't require you to have a physical device present at that time. You can download, you can debug, as Mike has demonstrated, just about everything you can do with a physical device. However, before you're ready to distribute the application, you should get a physical device and test your application on it. Our emulation is not perfect yet, and there are still subtle differences, so you still need to verify on physical hardware. Once you're done with that, you're ready to bundle your application and distribute it to your customers, be it over the web, on a CD, however. But you have to, if you're targeting, say, the HPC Pro, for an example, you have to batch build all the processors into one large cab file. Here's an example of how you would have to do that. You take your source code, compile it with the appropriate SH3, MIPS, and SA1100 compiler and linkers, and bundle them all into one large cab file. Then when your user goes to install this cab file, they have to take the whole file, put it onto their desktop, and download it over possibly a very slow serial connection to their device. Once it arrives on the device, the WCE loader opens up the cab file, extracts the appropriate CPU, and throws away 2/3 of that same cab file. So you've just wasted 2/3 of your user's time in installing your software. Allow me to introduce you to the future of application distribution with CEF, the Common Executable Format. As you saw in the keynote, you take the source code, you target the generic CEF processor for a platform, and then you include that single CEF executable in the cab file. Then the translation can occur one of two ways. There's desktop translation and device-side translation. The desktop-side translation is used when you're developing and if you want to debug a CEF application. You take the CEF, once the IDE is finished compiling it, the IDE then queries with Platform Manager to the device to see what CPU is present. It then will invoke one of the appropriate translators on the desktop, possibly also generating a PDB file at the same time. It then creates a native form of that exe, which is then copied down. The other alternative is if you have Pocket Internet Explorer or something on a palm size, you're browsing the web, you've downloaded a CEF directly to your device, and you just want to run it. Then you have the CEF on the device. It invokes through Birch SP2 forward. They will have a OS hook that will detect CEF executables and translate them. Or for older devices, we'll be offering methods where you can install the translators into ROM. And then you're left with the actual PE executable. The translated file size will be no larger than 20% of a native form, and the execution speed will be at least 80% of native, if not better. Right now, we're going to switch over to show a demonstration of this technology at work.
And we're going to show you a little different example than the one you saw in the keynote. I'm sure that seeing the same thing over and over today wouldn't be of great interest. What I've done is I've preloaded my workspace with one of the samples out of the SDK. And I've used this because it happens to be something that you'll have access to when you get back to your office or home. The sample that I've elected to use is the spin test sample. And what we're going to do is we're going to target the CEF release processor. If I was going to do this using the standard methods, I'd go in and pick MIPS if I was targeting my Mobile Pro, or I'd pick the SA1100 or ARM on the list here if I was going to target the HP Jornada. If I wanted to target a particular, say, an HP device, I might have to pick an SH3. What we'll do is we'll pick the common executable release, and we'll do a rebuild all, which will cause every part of this application to be rebuilt in CEF format. Once that's complete, the executable will be translated automatically and downloaded to the device. The first device I'm going to go to is the Mobile Pro. And once that's done, we'll switch over and take a look at the actual application running on the device. As you can see, it's comparable for performance to what you would expect had you compiled this thing using the native compilers. Now we're going to go ahead and switch back again, and instead of rebuilding the entire application, we're going to just update the executable, which will retranslate it and send it down to the HP Jornada. So I'll go ahead. Unfortunately, we don't have two screens the way they did in the keynote, where you can actually see us do both at the same time. Build. And we'll just retranslate it, show up on our HP. And we can run the executable on that side as well. And again, the performance is what you would expect had we compiled the same program using the native cross-compilers.
Thank you, Mike. Next, I'd like to talk a little bit about the VCCE futures and where we're headed with the toolkits. As Mike has already demonstrated with the Windows CE Wizard, we're now trying to more closely associate platforms with the given projects. Before, you could have multiple projects and platforms in the same system, and for example, you could have an Auto PC installed, and you've created an MFC application for an HPC Pro. You could easily just switch over and target the Auto PC, and there'd be nothing to indicate to you that the MFC would not run there because there's no MFC present on an Auto PC. We're also going to be moving towards the ability to create mixed 16 and 32-bit code. Today we have the ability for you with Birch SP2 compilers to create a 16-bit DLL and use it with the 32-bit XE. In the future, we'll even have tighter integration possible. Our toolkit is also now compatible with Visual Studio SP3, as well as including all support for the Birch SP2 processors. Next, we'd like to talk a little bit about some of the development tips that we feel you might be able to use and take away from this. First, I'd like to talk about developing for multiple platforms. For developing for multiple platforms, I'd like to talk about developing for a Win32 desktop application and a Windows CE application in the same workspace. What we recommend that you do nowadays is that you take and create two projects in the same workspace, one created for the desktop and one targeted specifically for Windows CE. Then you take the same source files and simply include them into both projects. The other thing that we would recommend is that you try to create, when you're creating your project, if say you want to target a palm size and a HPC Pro or some other class, try to allow for dynamic resizing of the dialogues and functionality of your applications at runtime. The other possibility that you can employ is if-defing the code so that if you have a palm size dialog, you can if-def that, exclude it from when you're building for an HPC Pro, for example. Next, I'd like to talk about ActiveX controls. It's very possible to take an ActiveX control that you're used to using on the desktop and bring it down to the Windows CE space. However, there are a few things that you have to be aware of when you're doing this. First, you do have to create an NT version of that same control for use in design mode and dialog layouts. Because CE isn't running on the NT, it's a slightly different control, so you have to work around that. Next, there's also no out-of-process server support in CE, which means that there's no marshalling support available. There's no single thread apartments, which means you can't rely on the OS to synchronize access to your objects. What you have to do instead is you have to use the standard Win32 synchronization objects for that. And now Mike is going to take a walkthrough of how to do some optimizations on one particular program for MFC, and also how to bring an MFC from the desktop down to the Windows CE space.
Okay, a great article. I don't know if you guys have seen the issue of MSJ that was done for DevCon, but there's a great article in there about the toolkits. Along with the article, the author, Steve Zimmerman, provided a version of regedit that can run on the device. Now, being developers, I'm sure you realize how valuable that is. When I read the article, I thought, what a great application to use as a part of my demo here today. It was written using MFC. It demonstrates some very interesting programming tricks, including the ability to rearrange his window panes depending on which size display he's actually running on. I was playing around with the application in preparation for my demo, and I noticed that it runs at least it starts up very slowly. What I want to do is I want to take a look at the application that you can get from the Microsoft MSJ website. And the address for that website's in the MSJ. But we'll take a look at the original version here. And as you can see, I've launched the application, and I'm waiting. OK, there it is. You know, about 6 seconds, 6 or 7 seconds went by there while I waited for that application to show up on the screen. So I thought, my Mobile Pro is no slouch. I mean, this is a pretty quick device. Why did it take so long to start up? Once I started looking at the code, I realized what he had done. He attempted to load the entire registry hierarchy at startup. Now, obviously, a cleaner approach would be to load just the top-level structure, and then as I expand nodes that I'm interested in, I load the remainder of that hierarchy. So what I want to do is I want to take a look at some of the code changes that I had made to try and improve the performance of this application. First, you'll notice the application is composed of a number of modules, and I'll just quickly run you through them so you have a groundwork to work with. The regedit CPP includes the initialization code, support for the main application windows in mainframe as usual. The data view, which contains the right side of that application and displays all the data values, is handled by the dataview.cpp file. Edit, value, and find dialog are pretty clear as to what those are going to do. And then the regview module handles the left side, or the tree hierarchy of the application. We're going to take a look at the regview module in a little more detail, and that's actually the one I have up here. If some of you in the back want to move forward, feel free to do so if you can't see very well. This application, there's a couple of key routines that we're interested in. The first is onInitialUpdate. The onInitialUpdate routine is called by the MFC framework after the view has been created, but before it has been displayed. And this is the place where this particular application chooses to initialize the hierarchy for the registry. It also is the place that they choose to set up the tree control and a few other things that need to happen in there as well. The solution to the problem, like I said, is not to load the entire registry structure at this point, to wait until somebody asks to expand a particular node. So to do this, we needed to add a new message handler. Right now, this application doesn't really pay attention to the expanding tree notification that comes through at all. So to add a message handler, what we need to do is go to the code that we're interested in. We're interested in the regview class. And we'll go ahead and add Windows Message Handler. And we'll get presented with a dialog of all the messages that we could add to our application. The message that we're interested in is the notification message for a tree view when an item is expanded. I'll add that message, and I'm going to go ahead and add some code to go with it, so I'll do the add and edit. The default name for the handler is fine with me. Typically, it's on whatever the name of the message is in MFC. And I'm presented with a new member definition, and I've got a little notification here saying I have some work to do. I'm going to go ahead and get rid of that, and in the interest of saving time, the block of code that I have available is in this other window, so I could just basically cut and paste. I don't think you need to sit here and watch me make all of the code changes. So we'll grab this block of code, and we'll stick it in our handler. A couple of the other changes that need to be made once you start taking a look at the code is, let's go back up to our onInitialUpdate routine. And as you can see in this routine, I'm going to go ahead and get rid of this window to give you a little more of a view. One of the things he does at the very beginning is he goes ahead and he inserts a node in the tree, which is for my device, which is the top-level node. And then he inserts a node for each of the class hives. Okay, so we have one for the classes root, current user, local machine, and HT users. Now, the important thing for us here is that after he's done doing that, he calls a function called addAllChildren. And addAllChildren, as we'll see in a moment, basically recurses through the entire tree structure for that hive and loads all of the information into the tree view. We're going to go ahead, since we don't think that that's necessary anymore, we're going to go ahead and comment that out. A couple other changes I'll make while I'm here is what he does is he's added this top-level node called My Device, And then he says expand that node, which will make visible the 4 hives, which is the typical behavior you see on the desktop. We're going to go ahead and leave that. The update call, however, since this window isn't currently visible, remember on initial updates called before the view is actually made visible, we don't need to bother to do that yet. And the fill item list, as a part of some of the changes I'm making here today, I've actually broke his find logic. It's very dependent on the fact that the entire tree structure has been loaded into memory. I haven't loaded the entire tree structure anymore, so the find won't work properly. The fill item list routine is entirely responsible for buzzing through the tree and building a dynamic array, a C array, that the find logic can skim through and find a particular entry. A better approach might be to actually scan the tree only when a find command is executed, which isn't as frequent as browsing the tree would be. So we need to go down to the add all children routine, which is the one that we've commented out of the top. And I'll explain why we commented it out when we go take a look at that block of code I threw in. But basically, as you can see, this routine takes a root node, gets the key, enumerates through the keys, and then recursively calls itself on the node that it just added. We're not interested in recursively calling into this routine anymore. We only want to load one level of the tree at a time. So we'll go ahead and comment that line out as well. OK, so that takes us back to this chunk of code which I added earlier. Basically, what this code does is when you click on a plus sign to expand a node in the tree, this message will get generated, picked up by the application, and this code will get invoked. When this code gets invoked, we have been told which node is being expanded. So what we need to do at that point is to look at each of the children of that node and load all of the information for that level of the tree. Okay? So that's what this code's doing. The important thing to notice here is that we only do this once. So if your application you've already expanded a node, we'll have children for this level of the tree. We don't want to reload that level. So there's a check in here to make sure that we don't do that. So at this point, all of the changes that we need to make to the application have been done. And what I'd like to do is go ahead and build this for the MIPS device again. And I'll do a rebuild all. Theoretically, if I've made all the changes correctly, this will build successfully and download to the device. OK, so the application's done building. It's been downloaded. Let's switch over to our device. We now have a new version of regedit on our device. And we'll go ahead and run this version and see how it does. And now we're down to about a second to load this application. So the thing that I think is important to take away is always to take a look at what you're doing in your initialization code. You want to defer any work that you can till later in the application, if it's possible. Now, certainly there's times where you have to do something at a particular point, and you can't get around it, and there will be a delay. But in this case, this application works just as well now as it did before, caveating the find problem. And the perception is that the application is better because it starts faster. OK? So that gives you just a brief overview. Again, the original source code for this application is available from MSJ, because if you're like me, having a regedit on your device is extremely handy. The remote tools are great, but you have to be connected to a desktop at that point. I see that there's a hand up. Can you wait until the end, and I'll be glad to take your question? Oh, I'm sorry. You want to see me expand a node? OK, let me grab, say, local machine. Is that fine? And so there's no real noticeable delay in expanding that node. Let me give you even a better example, because classes root is probably the largest node in the registry, and so it'll have the biggest impact. And again, there's just not any real delay to using it. OK. I'm going to let you go ahead, and I'm going to set up for your next.
Yep. And I would also urge you to take a look at the source code, notice the changes that Mike has made, and also read all the other articles targeted about Windows CE in this journal. It's a great article and great magazine for this conference. The other areas of Win32 and MFC we're trying to continually trying to improve our MFC experience for Windows CE. And if you have suggestions or feedback, we're always open for any of those possible ideas that you might have or things that would really make your life easier for development under Windows CE. And I believe Mike is just about ready again.
Okay. Now, the next application that I'd like to show you is that I'm occasionally asked by people, you know, how does MFC for the desktop and MFC for the Windows CE device compare? And so what I'd like to do is take you through a quick demonstration of taking a wizard-generated MFC application for the desktop and porting that down to the Windows CE device. We'll start by creating the desktop application, and I do that again by starting with the new project wizard. And this time we'll select the desktop application wizard. We'll just call this sample, targeting the Win32 platform. And another thing that you'll get out of this is you can see that the Visual C environment with the toolkit added still supports Win32 development for the desktop as well as development for the Windows CE devices. I'm going to select a single document interface. As I explained earlier, we don't support MDI applications on Windows CE. I can click Next. I'm happy with the default database support of none for this example. ActiveX control support is included in our application. And now we're up to the feature page where we can include which features we want in our application. We have an initial status bar, print and print preview support, 3D controls, and I'm going to go ahead just for consistency and use the Internet Explorer rebars again. Shared DLL support is fine, and again, the default names are just fine with me. I'll confirm all my selections, and I'm building my application for, we'll do a release build this time. So again, I'm compiling for the desktop at this point. I haven't done anything to convert our application. Just want to show you that the application does get generated and the code actually works. Okay, so our application's been built. We'll go ahead and execute our sample. As you can see, we have a menu bar, we have common dialog support, and we have print support. All of the same things that we had when we used the MFC wizard. Now, I'll go ahead and get out of here. And the first thing that I need to do in order to make this a Windows CE project as well is we're going to go ahead and add a new project to our workspace. We'll select the Windows CE wizard this time because I'm interested in a CE project, and I'll just call it CE for simplicity. This time, I'm going to choose the Windows CE application because this is the simplest way to get an empty workspace. And then I'll modify that workspace to do what I need. Confirm all my selections. And we patiently wait as the new project's added to our workspace. Okay. And now, the first thing that we should do is make sure that we have all the same files that we used in the original desktop project. So I'm going to add files to my project, and I'm going to select all the files that are here. And we don't want to forget the resource files, so I'll go back and grab those separately since they're in a different directory. Did I miss something there? Sorry. Okay, we happen to have 3 resource files that we'll also include in the project. Okay, so at this point we have all the files that we used on the desktop. Now we need to modify the settings for our application. We'll go ahead and build a release version when we're done, so I'll make sure that I'm modifying that set of settings. First thing that we'll do is we'll say that we are going to use MFC and we're going to use it in a shared library. The other important thing that needs to be changed is that I want to go ahead and take advantage of precompiled headers for my project. So we'll use precompiled headers through standard afx.h. And we need to make sure that we also create that. So we'll create this precompiled header using the same syntax. So my settings have been made now. Now we're up to the changes that we need to make to the source code. And there are a few changes that we're going to have to make, but I think as you'll see, they're fairly straightforward. Let me go ahead and start with sample CPP. Print preview support is not available on Windows CE. So what I'm going to do is I'm going to say if we're not running in Windows CE, go ahead and include that support. Otherwise, turn off print preview support. And the second thing that we're going to have to change in here is that Windows CE is going to use 3D control by default, so we don't have to do anything special to enable them. So I'm going to use the same logic again. If we're running under Windows CE, we won't do this. Otherwise, we'll go ahead and do it for the desktop. Save the changes to that module. And sample view happens to be the module that contains the handler for the preview support. So what I'm going to do is I'm going to go ahead and jump down to where that's defined, and I'm going to comment that out as well, only if we happen to be running on Windows CE. All right, and so those are the fairly straightforward changes. Now, the more complex change comes in mainframe. A Windows CE application handles menus subtly different than the desktop does. So what we need to do to enable our command bar support is we have to add a little bit of code here. And I have already put this code into the routine, into my paste buffer, so that I can just drop it in. The first thing that I've added here is I've added support to create the menu bar. And then the second piece of code here, I'm going to go ahead and grab and move that to a different part of the module. Down here, when we actually create the rebar and add in all the different things like the toolbar and the dialog bar, I'm going to go ahead and stuff in support that will also add the menu bar and adornments. And adornments in the Windows CE sense are things like the Xbox. And the last module that we need to change to make this application work for Windows CE is to jump over to the mainframe header file, because we just added a menu bar, but we don't currently have a member that will store the handle for that. So we need to go ahead and drop that in our code as well. Okay, so what we've done is we've added that member, and now, assuming I made all those changes correctly, we should be able to do a build for our device. And again, after the build's complete, it's going to go ahead and download to the Windows CE Mobile Pro. Uh-oh. You know, that never happened when I did the... Did I? What did I misspell? And you didn't say that until now, huh? Okay. Let me make sure I get them both. Did I get the other one right? Yep. All right, do a rebuild. Much better. Okay, so we've downloaded our application to the device. Let me go ahead and switch over there. And we have this application called CE. I can go ahead and run that. And as you can see, it's very similar to the application that I created using the Windows CE Wizard directly. I have a menu bar. I have common dialog support. I have, assuming I can click there, I have printing. I have an about box. And remember, all this code was generated using the desktop wizard and then subtly modified to work on the CE device. So you can see the two are very similar. You can use very similar techniques to do the ActiveX control and have a desktop and a device version. And you see that they're both present in the workspace, and I can build for either one.
Thank you, Mike. If you can switch me over.
Yep, sorry. There you go.
In conclusion, I just wanted to say that we've covered a lot of the new features that we're releasing in the 6.01 Toolkit today. I would urge you all strongly to, when you fill out your evaluations and get the CD pack, take it home, try it out. There's Platform Manager, a great way to connect to and debug devices using the TCP/IP protocol and new other protocols. CEF, the new application distribution technology, simplifies your customer experience for distributing applications for any given platform. What should you do next? Take the toolkit, install it, run your favorite apps through CEF. We need your help to figure out if there are any errors in this. This is still preview technology. We need feedback on this. We want to make it the most solid, best, most stable technology possible for your customers. It needs to be able to handle anything. Try using one of the SDKs that you saw generated using Platform Builder. Install it. See about targeting a Maxall configuration or making your own remote control unit or a mini robot or something. And most importantly is give us feedback on what you want to see next in the toolkits. How can you do that? There's 2 web pages on this page, which you should also have in your slide printouts. And there's the Windows CE Tools wish alias, where you should send any feature requests. We read these, we monitor these. The more we hear about somebody wanting something, the more likely it is to get implemented. And the bug reporting if you have any errors with our products. At this time, we're happy to take any questions. There's a microphone in the center if you want to go to that, if you have any. And
which demo? I don't currently have them, but we'll make sure that they are available. One of the things is that you'll notice that we've made a couple of changes to the slides if you happen to be watching them when we were going through them. And a final version of those slides will be posted on the website, so we'll see if we can't get some of this other stuff posted as well.
yes? I believe it does. All right, does the emulator have database support? And I believe it does with the object store, the inbox. Somebody's at the microphone there?
Yeah, I have a question. I've been supporting CE devices for a really long time, and now that international versions are starting to come out of some of the devices, or at least they're being used, I have problems of, due to the directory structure and so forth, being in different languages, like program files not being program files, it's being whatever it is in French or something. Where, and I've been trying to find, can I get a international version of, well, actually a device, which I haven't been able to find, or a emulation, so that I can see the environment itself with all the directory structure as the operating system is set up.
There are Japanese versions of the toolkits that are out presently that include emulation. I believe if you go to the Microsoft Japanese webpage, you could find pointers to those there.
I'm looking for the, I guess, Romance languages like German, French.
The German and French. There are currently no versions of the toolkits in German or French. We are moving towards making them worldwide English compliant, so you could develop on a German-based OS system.
At this point, there aren't any versions of emulation that aren't in Japanese or German.
Or English.
And English. But the other Romance languages aren't currently available. As to where to get devices, I don't have a good answer for that.
Well, what's happening is that the vendors, or the OEMs, they're building these devices, and you know, they're changing things, nationalizing it, and then it's very difficult to, you know, to support it. So
yeah,
some feedback you asked for. So
I would suggest the best option would be there is to talk to the actual OEMs that are making the devices and see about getting evaluation editions or asking them to be able to buy the international editions.
I have, and they say see you.
In front there.
Are you gonna?
Can you say that again?
We'll repeat the question even if he doesn't get to the mic for you.
Yeah, we just need to hear it ourselves.
I know.
If I do have ID installed in my system, how to translate the CEF bar and then download to the HPC system?
If you don't have...
Because when I ship the product, I don't expect the customer have ID installed in their system, right?
You mean the translators?
Okay, the question was, you know, how do I translate a executable for my customers? And the answer to that is your customers are going to be using the device-side translators. So typically they're going to be getting your application, say, off of a web or some other method that they're going to get it directly to their device. And then when they run it the first time, there's hooks in the OS or the device-side translator will be available on the device so that they can translate that executable to a native format.
Or the other option would be if you need to distribute the translators, if you feel it's too new of a technology, they're only about 200K all told for a various processor. So you could include those as a supplement on your website or your application distribution.
Okay, now we'll go to the mic.
I have two questions. The first one has two parts. Do you participate in the Microsoft CE Developers Newsgroup, and if not, why not?
Yes, not as frequently as I should be there, but I do monitor the news group, and I monitor the aliases, and I pay attention to what I see there. And the more times I see something requested, or the more common I see a problem, the faster we can address it.
Thank you. The second question is, when you were doing your samples, regedit and the last sample, why did you not create it as a CEF?
Why didn't I do it as CEF? I didn't do it as CEF because I figured you were going to see a lot of things getting translated to CEF, and I just thought you might get bored with it. It works with CEF. I actually did regedit before the conference. We thought about using it instead of the spin test, and we just used spin test instead.
Thanks.
A couple more questions. I seem to remember there used to be a remote memory viewer tool.
I'm sorry, I did not hear your question.
Didn't there used to be a remote memory viewer tool in one of the previous versions of the toolkit?
I'm getting some echo. I can't quite make out what you're saying.
Sorry. There used to be a remote memory viewer tool, I think, in one of the previous versions of the toolkit.
The 6.0 or the 5.0 toolkit?
Probably the 5.0, but it seems to have vanished.
I didn't hear the question, so.
Okay, I sort of half heard it. So, remote memory viewer tool?
Thank you.
Thank you.
See, I think the microphone works really well for you out there because it seems to come out of the speakers back there. We don't hear it up here. So using remote memory viewer, what was the question?
It's vanished.
Oh, where did it go?
I'll investigate that and try and get you an answer. See me afterwards, and I'll try and get an answer to you about that. I don't honestly know right now.
Okay, another question, if we can actually get this one through the mic. The emulation. Is the idea eventually so that I only have to build one executable? I can run it under emulation and actually on the x86 device? Rather than having to link to...
I don't. Can you step away from the microphone and yell at me? Because it seems to work a lot better.
The emulation, currently you have to build two separate versions, I believe.
Yes.
The emulation and one for the actual device.
Yes.
Is this ever used so that effectively the emulation is for real and I only have to generate the one executable?
Emulation is a different processor, right? We're on an x86 when we're doing emulation. So you're always going to have to, if you want to build for native, you're always going to have to target x86 as your processor.
Sorry, I should have said, assuming the device is actually x86.
Oh, assuming the device is x86.
Presently, there's no way to target for emulation because the emulation is actually a stubbed version of NT. So there are inherent differences between it and the CEOS. So
we definitely recognize it as an issue, and we're exploring ways that we can improve support for emulation. Okay? There will be a translator available for emulation.
Yep.
It's not in your preview kit. Yes?
Yep.
Microsoft, during your presentation here, suggested that projects be divided between different platforms, such as x86 and CE, by sharing files between the projects. Under 5.0, you used to be able to mix those two environments.
Wow, I'm amazed that it made it this far into Q&A before that question came up. And actually, it wasn't a question, it was a statement. And yes, you're right, we did. We eliminated the ability to have mixed projects starting with the 6.0 release. And we understand that that's been a problem for some people. Not everybody obviously develops for both the desktop and for the device, and there are ways to get around it. But we do recognize it as an issue, and we're trying to figure out ways that we can improve that level of support.
The second question regards debugging on a CE device from an x86 desktop.
Yep.
Whereas not all
Well, I'm not sure what you mean by it won't work. I've played with it, and I know that theoretically it does work. At least it's worked for me. You're obviously not going to have debug information available, and you're going to get dropped into assembly language when you try and enter one of those modules that doesn't have debug information. But you should be able to go through the debug experience and actually debug code that does have symbols.
In our experience, the debugger stops at the point that it attempts to statically link the DOL as opposed to dynamically load the DOL.
With MFC?
You mean implicitly link?
No, it's not MFC, it's just straight C or C++. There's no MFC on top of it.
Yeah, it's not something that I've heard before, so I'm not sure exactly what to tell you, but I know that it does work. We've used it. It's not the most convenient debugging experience because obviously there's a big chunk of code you can't get to very easily, but it does work. So if you could give me some more details, send us a message on the bug alias and tell us what you're encountering, and we'll get to it. Can't tell you when we'll get to it, but the number of people, the more people that submit a problem, the more likely it is that we can get it fixed.
You?
Yeah, Ethernet debugging
Yes.
support is wonderful. In the Visual C++ 6.0 beta release, it was incredibly fast, but when the real release came out, the performance dropped off dramatically. You guys planning on speeding up debugging over Ethernet? Because single stepping on a strong arm, for example, is about 6 seconds per statement.
I'm not sure why you'd be seeing that. My experience has been that single stepping is 1 to 2 seconds using Ethernet debugging under normal circumstances. So I'm not exactly sure what would give you that kind of performance, but I do know that our debugger group is very concerned about the debug experience, and performance is obviously the #1 item on their list. So they're constantly looking at ways they can improve it, not only for Ethernet, but also for serial.
Another question was that as a result of 6.0, I had to split my code up into 2 separate workspaces, one for desktop Windows and the second for Windows CE, which I don't consider a problem at all.
Okay.
I'm perfectly happy having it that way.
And you're now my next best friend.
The problem is switching between the 2 workspaces.
Projects or workspaces?
Between the workspaces.
Okay.
I have a workspace for desktop and a workspace for CE.
Okay.
And so, for example, I make some changes on the CE version, go back over to the desktop version. It's the same code file with a whole bunch of if-else in there.
Is there a reason you chose to do it as 2 separate workspaces instead of 1 workspace with both projects?
I think I should know you can do it that way.
Okay, so there's a way that I think you'll get better results, because then you can just set active.
So the problem is I then hit the build button, and basically Visual C then deletes all the intermediate files and forces a complete rebuild all over again.
Okay.
Which really slows things down.
Yeah, and that's a really good point. And what you'll see coming in the next release of the toolkit is a part of the platform work that we've shown you here today, where we've segregated out the wizards by platform. Some of the stuff that we didn't show you, which is also in this version, is once you've generated your wizard project and you take a look at the platform dropdown that's in our IDE, it used to be that every platform that was installed on your machine was visible there. Now, only the platform that you have created that project for will be visible. Now, you can add additional ones there, but you don't just get them all by default, because the whole point of this is that we generate code out of a wizard that actually runs on a device. Part of the work for doing that will mean that to fully support platforms properly, when you did, say, a batch build. Today, if you do a batch build with the released 6.0 toolkit, and say I'm targeting an HPC Pro and a palm-sized device, when I build all my processors for the HPC Pro, I have a whole set of processors out there in the directories, and then I turn around and rebuild for the palm size, and it overwrites everything I just did. Okay? And that's pretty much the same thing with the desktop. To fully support batch build properly using the new platform model, we will actually create a new piece of hierarchy, so platform will become an element in the output directory structure. So now you'll be able to retain all of your HPC executables as well as your palm and desktop. So I think that'll address the problem for you.
Can I throw in a couple of comments?
Sure.
Related to that. Number one is that the batch build dialog is appalling because it's not very sizable. I don't know if you've stared at it, but if you've got one main executable and 15 DLLs targeted across release and then debug across 4 different processes, the list is colossal.
And that, yeah, I was going to say, that's not the only dialog that has that problem. And we are going through and trying to fix those. I have to admit that that level of support is slightly below some of the other feature work that we're trying to get in. So I can't promise you which things will actually make it into the next release by the time we hit RTM. But we are trying to address those, and you will see all of them cleaned up in the next few releases of the product.
I think there was a question in the middle there. We're part of the Windows CE Tools organization, so we work very closely with the Platform Builder team. They are separate teams, however, but like we're all in the same group, so features that we do tend to migrate over. I believe it's there today.
What exactly do you mean when you say MFC? Do you mean the ability to include the MFC runtimes in ROMs? The MFC wizards?
No, it isn't. And I don't believe they currently have plans to include that because they're not trying to create Platform Builder to be equivalent to the VCCE toolkit. They're not focusing on app development or app debugging or anything like that. So that's why they want you to use the exported SDKs with the VCCE toolkit.
It's an interesting comment, though. I mean, we'll certainly carry it back to the Platform Builder team.
In front there.
One improvement that would make our life a lot easier is if you could color the egress so that the program you had before, if you had the same gray out the egress that do not apply on that particular build, it would make our life a lot easier.
Okay.
Okay, thanks. No, that's the mic.
I think you'll be able to hear me. I'll speak very close to the mic. I'd like to add my voice to all the people who have been complaining about having to split CE and Win32 projects into multiple projects instead of the same. My company ported 1 million lines of code and greater than 50 projects into 5.0, and we use the multiple configuration in a single project. So it's going to generate a huge amount of work for us to go back when we do support or port it into 6.0 to redesign all of the projects. That's the first part. The second part is that the multiple projects does not work well with some source code control systems. For instance, we're using MKS source integrity, and it just goes into conniption fits if you try and include the same source file in different projects under source code control. So what you need to do, which is a rather poor solution in my opinion, is to include that source file in only one project under source control and leave it not included in the other, which is pretty inconvenient because then you can't use all of the IDE things when you're working in that other project, et cetera, et cetera. That's my comment.
Yes, that's the difference between file-based and project-based version control systems, right? I mean, a project-based version control system understands that this file can be referenced from multiple places. It's something that, yes, we should consider, but it's also something you should be speaking with MKSers well about and let them know that you have this requirement and that a tool like this, requires you or currently requires you to do it this way, and maybe they can also help you. So there's 2 vendors here I think you can go to. You've come to us, we'll take it as a comment, we'll go back with it. But I'd suggest to you, no, I mean, I'm not trying to, really I'm not. But there are some things that they could improve on as well in their tools. I've used MKS for years, and I love their tools, and I've given them a ton of suggestions over the years. So I know that they're pretty receptive to comments from their users. Yes? You know, a question that starts with when will hardly ever gets answered directly. But when will the emulation environment support what?
It's something we're investigating, and we'll.
There's no specific time frame available to tell you for sure you'll have it on this date, but it's definitely something that the PB team understands is important for being able to roll platforms and do debugging. It's a good comment. I agree with you 100%. You absolutely need emulation. Yep.
Yep. It'll be the translators and the runtimes associated will be available in the platform builder so that you can include them into ROM on your own custom embedded devices.
Device side translators and the runtime for the device will both be included in the PB product.
Right, but if I created a platform which didn't have certain components and it compiles them with the CEF compiler, so is the translator going to flag those problems?
What you're saying that your application takes advantage of features that you didn't roll into your OS?
Right.
Well, remember that when you build your application, you're building against an SDK that's been exported out of Platform Builder. So if the features aren't there, you're not going to be able to compile. Because you're actually building against regular exported headers. And so it's the same as any other native processor from the development perspective. It's just a distribution enhancement.
And also, just if you're curious, the translators themselves will run in a min-current OS configuration. So you need no real OS components present in your OS to run the translators. Yep.
The largest setting utility to translate the CEF from 5, then we can ship with alpha.
The translators, you mean?
I'm not sure I understood your question. Are you saying if we shipped a utility to translate the executable, then you could ship the translated executable? Well, that doesn't buy you anything because you could have just built native in that case. What really buys you here is being able to ship one executable that will run on lots of different platforms that can be translated on the device by the user. So that's the real merits of that technology. Uh-huh.
Do you have any idea of the overhead, the extra overhead created by MFC as opposed to a plain vanilla Windows application?
What do you mean by overhead?
Size and performance.
Size of the application is definitely bigger, no doubt about it. Which is true on the desktop as well. The MFC runtimes that we ship are significantly smaller than those on the desktop. And the article that we mentioned in the MSJ has a nice little table that shows you all the different runtime sizes so you can get a good feel for it. And one nice comment he made in the article, which I thank him for, is that we've been able to keep the sizes of those runtimes down even though we've been adding features to them. Performance-wise, you know, once you get through initial startup, you're pretty much running at the same performance.
Why did you remove support for exceptions?
Remove support for exceptions? What exceptions are we talking about?
C++ exceptions.
We've never had C++ exceptions. The OS, we require OS support for C++ exceptions, and that feature has not been available in any current shipping OS. As soon as it becomes available, we will add that support into our toolkits. Okay?
Yep.
There's a number of functions that are missing from the standard runtime library. The runtimes that we use on the CE device are scaled down, and so if you were looking for things like maybe streams, you're not going to find them. We also understand that that's an issue, and we're trying to improve the number of APIs that we have available out of the standard runtime.
Yep.
On your available emulators, what do you have in terms of auto PC? I'm looking for support for large screen, something other than the 1 gig automotive screen, which is, I believe, the 200 by 64 or 164 by 64.
So the question is, do we have large screen emulators for the Auto PC? I don't believe that we have them today. As with any targeted platform, they're probably planned and will be delivered at some time, but I don't know any expectations of when they would be out.
What's the easiest way to keep track of that? Just do your website there?
The website's a really good place to keep track of it, and the news groups are also a good place to keep track of that kind of information.
Is there any plans to upgrade the resource editor for that particular platform, the Auto PC? Because we've got a group of people that it's a new technology. I don't know what version of the hardware that you guys have run with, but if you haven't seen the resource files before, you're breaking into it, it's brand new, familiar with an NT desktop version, and you have no support there when you go to your resource files. And a lot
Yeah, that is something we've become aware of, and we're trying to figure out methods to address it. I couldn't tell you when we'll have something ready that would address that particular need, but it is something we are aware of and are looking into.
And one other question, you run the 6.0 with the Apollo reference platform?
The what?
The AutoPC hardware?
You asking about us personally? The two of us standing on stage, or Microsoft in general, or? Huh?
We're back at 5.0, and for some reason, I don't know why we're still there.
I believe the SDK wasn't updated to take advantage of Platform Manager, which is required for the 6.0 toolkits. And I believe that work is being done and will be released soon.
All right, it's just that we're kind of out of the information loop. Not
Yeah.
I don't have a good answer for you. The SDK teams, the people who provide us those components, are actually separate. And we do track what they do, and we do provide components to them. But specifically when they're going to have certain features available, I don't know the answer. But if you send in your comment on the wish alias, a lot of the program managers for the SDK group monitor it, and I'm sure that they'll give you a response. Yeah?
Some of the processors have floating point processors.
Yes. Uh-huh.
Toolkit support carrying floating point instructions.
Yes, we do. What we have is we have different, so for example, the MIPS 4300 is a floating point processor. And we have in the IDE a new processor type called MIPS FP, which is MIPS floating point. And there will also be support for others like the SH4, which is a floating point version of the SH3, and so on. So yes, the toolkit does support those. Does is C++ exception handling?
CEF, you mean?
Oh, CEF. There will be translators available for floating point chips. They're not currently in the preview. Does that answer your question? Okay.
Yep.
Do you know if there's any map, any poster of the support APIs for Windows 8? Something hang our wall and see.
I don't know whether there is or not. Did Bowling's book have a poster? The Programming Windows CE book? I don't remember seeing one. Yeah, no, I haven't seen one, to be honest. Okay, so there you go.
Thanks.
MFC or Win32? Okay, were you asking about Win32? Okay.
Okay.
All right, so we're going to start wrapping up. We'll take another question or two, but I want to go eat lunch too.
Yeah. Yes?
I was wondering, yeah, in this map you can do like a GPU and this power processor.
That's something the OS team would be able to answer. I know it is as every
Let me
feature.
answer that question indirectly. Did you attend the keynote today? Yes. Did you see the slide that talked about Microsoft Message Queue? There was a little blurb about Microsoft Message Queue. I'll leave it at that. Any other questions? Okay,
No?
great. Well,
Great.
thank you all for coming.
Thank
I
you.
hope you enjoyed it.